sorry, my bad. Websites.
Hi everyone and welcome. Thanks for coming to another UK Azure user group. Some new faces in the crowd, so that's nice. So a couple of announcements. Firstly, I wanted to show you this new initiative that we were piloting. Some of you would have been coming to the user group for a very, very long time, 7, 8 years plus. You know, one of the things that we're trying to do is Microsoft were kind enough to fund the food and drink and things like this, and you know, a lot of companies sponsor these events. So if you do have a company that wants to put money into like a sort of slush fund for user groups, whatever it is, then we're trying to get a sort of not-for-profit initiative up. My company sponsors a lot of events, but like us, there's recruiters, there's other Microsoft partners, and all kinds of people. So if you've got an employer that might be interested in something like this and getting a bit of exposure and a little bit of goodwill by giving some pounds to the community just to sponsor beer and pizza, this goes literally all across the board, all across the UK. And people just take, you know, what they can out of it. So we're trying this as a new initiative. This is just a prototype website. We're going to make it look a little bit nicer, but it really is about giving the right kind of exposure for companies that have got marketing budgets, want to push their brands out, be associated with user groups, put things like videos and bits and pieces, because these things are hard to finance. We want to put on a good show, make more people come, and unfortunately that costs money. I totally forgot this month, because normally I just fill in when at venues that are non-Microsoft venues that the food stopped. So Microsoft weren't sponsoring food as of this month, but we've got 2 talks next month. So this is my screw up. But we've got 2 talks next month, and we will sponsor all of the food and drink. But from September, we've got a whole set of pledges already for this. So there's already quite a lot of support pushing this out. So this will be one of several user groups that this fund will be supporting. So I just wanted to put this out. At the moment, we'll get a nice domain name for it. At the moment, it's ukfund.azurewebsites.net. But yeah, I just wanted to put the message out there just in case any of you have got employers who've got marketing budgets who want to do something altruistic like this for the community. Okay, so just to follow up, I'll introduce our speaker in a bit, but next month we have DevOps month. Because we have 2 DevOps talks. So any of you that have got interests in DevOps, patterns and practices, using Azure DevOps, and some of the really advanced ways that you can do deployments, as well as different kinds of customers and their different tenancies and stuff, you should come to this. And also spread the word as well, because there's a large DevOps community that don't actually come to the Azure user group, so it'd be good to see some of those folk as well. Tonight I want to introduce you to Ivan Gavryluk. Please tell me I said that right. I should know after like 4 or 5 years, right?
Yeah.
Did I?
After all 3 years, 4 years I was working for you. That's all I get.
Okay.
Yeah.
Sorry.
Gavryliuk, yes.
So I got the first bit. Well, it starts with a G. So Ivan, for any of you guys that have ever studied Service Fabric, you should know that Ivan built all the original material for Microsoft, patterns and practices, for all the early stage e-commerce samples, and for things like Microsoft Learning. And he sort of branched out into building all of the Pluralsight courses for Service Fabric as well. And it's really been his mainstay. I haven't met anybody outside of the product teams who knows more about Service Fabric. And I was really, really keen to put this on, even though Service Fabric Mesh, which Ivan's going to be talking about, has been known for a while in preview. It's not really something that people have spoken so much about. And when we were talking to customers about it early stage, they would say, oh, it doesn't quite do this, or it doesn't quite fit my profile. Or so time has advanced since I had some of those conversations and it was announced at Build and Ignite. So I thought that it was high time that we had a talk on this. So I'd like to introduce Ivan as probably the best Service Fabric expert outside of Microsoft, which is probably not saying much because I think there's only 1 or 2 in Microsoft. And they both wrote it. So without further ado, Ivan.
Thanks, Richard. Hello, friends. So I'm Ivan, and I'm a software developer. I've been working with microservices for a long time, since 1982. Yeah, which is just called different, right? So it's still microservices. Yeah, I was working with Service Fabric since the beginning. I think before it became public as well. We had a really nice engagement with Microsoft, really nice people. Service Fabric team is probably one of the best in Microsoft. Really respect them. Today I'd like to talk about this new Microsoft offering, Service Fabric Mesh. I'm not going to take too much time, not like last time. It was 3 hours. Yeah, it's going to be just 1, I think. Maybe 2 or 1. I'm really excited about this new tech, as well as about Service Fabric, and hopefully you like it too after you see my slides and code. Does anyone know about Service Fabric, normal Service Fabric, not Service Fabric Mesh? Thanks. So essentially, what Service Fabric is. So the Service Fabric is Microsoft microservice platform. I'm not talking about Service Fabric Mesh yet. It's a large platform which hosts Microsoft Azure, at least most of the Microsoft Azure services, right? Technically, it's just a cluster of VMs or physical nodes tied together. And it's so powerful that essentially Microsoft Azure wouldn't exist without Service Fabric, right? It's a platform which Microsoft designed before microservices term was even invented. It originally was designed to run Microsoft Service SQL Server on scale in a cloud, and then it grew up to host the rest of the services. It's not for everyone. Service Fabric is mostly designed to run mission-critical applications. So where you need speed and security and nanosecond latency for your storage, this is where Service Fabric steps in. Therefore, you won't see too many applications built on Service Fabric today. Especially, it's mostly commercial applications for big companies who can afford it, who want to invest in the future. This is not as popular as web applications and so on, like Kubernetes as well, and other frameworks. So the Service Fabric itself is, why it's so good is because it's, it essentially allows you to write applications natively for the microservice platform using a very strong programming model. So it's not like everything else. You get a lot of open source components and try to glue them together, and then they just fall apart and nothing works. Or if you're lucky, you sort of make a stable platform, but it takes a lot of effort and time to do that. Service Fabric has lots of interesting concepts called reliable actors and reliable services. These are Service Fabric native low-level applications which power Azure. But it also supports popular trend today, containers. When I say containers, it's Docker, because other container technologies have died and Docker won. And something called guest executables. But essentially, it's a platform which allows you to run anything you want. Whether it's containers, whether it's application in any language, any platform, any OS, except for Mac OS, because it's not a real OS. It's not a server OS, all right. Sorry if I offended anyone. And for you as a developer, where you want to use Service Fabric is when you want to develop a stateful services. So services which need to work with storage. And the storage is really, really fast. And you can't rely on any external services like blob storage, I don't know, Event Hub, Service Bus, and anything which calls over the network, because it's a huge latency to get something over. So essentially, Service Fabric stores everything on a local disk. So if you have an SSD drive, this is your speed of storing and retrieving data. Plus, the data never, it actually never disappears because it gets replicated automatically. So that's the real power of Service Fabric. That's the only scenario I would recommend using it. Otherwise you have better choices which are more suitable for other workloads. Like for web application, it's Microsoft Web Apps. I don't know, serverless, it's Azure Functions, and so on. As I said, so Service Fabric powers most of the Azure, and this is the popular services, just some of them: Power BI, SQL, Cosmos, IoT Hub, Event Hub, Skype, Cortana, Intune, and quite a few others. So as you can see, the Azure DevOps, probably popular today, Ivan Gavryluk, Azure Container Registry, Stream Analytics if you use it, Azure Monitor, App Insights. So this is all working on Service Fabric. This is, it's proven to be a scalable platform designed for scalability, because you can imagine how much workload those services handle every day, every second. Therefore, you don't need to prove it is stable. You don't need to think twice because Microsoft has proven it for you. Moving on. Also, Service Fabric, it's available in a few options. So again, this is a platform which runs everywhere. Just like Kubernetes, which a lot of people talk about today. Service Fabric runs on-premise, so you can download an executable from Microsoft website and install it on your private clusters. And I believe someone in one of the other talks were talking about, I think, Vanquish Bank. They run Bank on Azure and Bank on Service Fabric. Service Fabric runs in the cloud as well, so it's not just Azure. If you look at the title of the product, it's actually called Service Fabric, not Azure Service Fabric. It runs on AWS, Azure, Google Cloud, and Microsoft Documents actually have step-by-step instructions how to install Service Fabric on AWS, which is really strange. There is another product offering called Azure Service Fabric, and this is slightly different. So it's an adaptation of Service Fabric, which runs in Azure and is more or less automated. So you can click a button and Microsoft will create a cluster for you with as many nodes as you want. and partially manage the cluster for you. So if you want, you can get automatic OS patching. You can scale your cluster and your applications. It's much easier than doing it yourself. So this is another offering. And obviously, you had full ARM support. So ARM, if you don't know, is a JSON language for describing resources in Azure. So you can describe pretty much every part of Service Fabric cluster with ARM. So that's good. Another offering, which I'm going to talk about today, is called Service Fabric Mesh. So yeah, to be honest, I don't know why it's called Service Fabric Mesh, because it has little to do with Service Fabric. I've heard people complaining about this name a lot, but we are stuck with it for now. Again, it's built on top of Service Fabric. It works only in Azure, so no other cloud supports that. It's a platform designed to take out any infrastructure problems from you. So you don't need to create clusters anymore. You don't need to manage them, and it's fully serverless. So just like with Azure Functions or AWS Lambda, you just host your code, right? Any questions so far? No. All right. So why Microsoft created this new platform, Service Fabric Mesh? So the reason for that is that containers are getting more and more popular today, right? They are winning the server wars. And to be honest, Service Fabric is, well, although it supports containers, it's not as easy to run them. So Microsoft runs containers on Service Fabric. So in fact, Azure App Service, container services for Azure App Service are hosted on Service Fabric. They are powered by them. Azure Container instances are hosted on Service Fabric and so on. But it's very hard to create an application which is containerized and runs on Service Fabric. It's not as hard as on Kubernetes, but it's hard. Therefore, this new offering, so Service Fabric Mesh, they are trying to make life easier for you, right? And now your teams of developers and ops don't need to talk to each other, right? So this is like a dream of a developer. You don't really need to talk to people, or you talk less now, right? So with containers, right, or whichever tech you use in Kubernetes, container instances, something on other clouds, you create your code, you write it working on your local machine, and then you create a Docker file and hand it over to ops, and they deploy it for you. So it's pretty clear, the language which both parties understand, Docker file, this is how you communicate. You commit it to Git, and they read it, right? This is good for a lot of companies, especially enterprises, where every single person who feels important needs to approve which technology you use in Azure. It can become a real mess, but if you use containers and Dockerfile, you just deploy this sort of image, and it just runs. It's wonderful. So essentially, now you have a native offering on Microsoft Azure to run containers. This is great. No servers, nothing. Containers are great today because you essentially get portable workloads, right? You create this image, and it can run on Azure, AWS, on-premise, anywhere else, on the ship, on your phone, and anywhere, right? This is what containers promise us. So you can run it anywhere. Until you actually try to run it somewhere else. It runs anywhere, right? So this is a popular thing. Actually, one of the things which works is portable resource governance. So you can limit how much resources your application use by saying, well, I can cap it to 1 gigabyte, or I can cap it to half a CPU, and you can eliminate these noisy neighbors on the cluster. But I'm not going to talk deep about that. This is just something I noticed, and I'm sort of excited about it. And of course, ease of deployment. So, like in old days, you had to install some SDKs and frameworks on your virtual machines. This is not happening anymore. You just drop an image and it runs. Wonderful. So essentially, Microsoft is trying to keep up with this trend, and Service Fabric Mesh offering is about enabling that. And again, you can run it on any cloud, on-premise, anywhere. So good. Right. But now, essentially, when you try to deploy a container, the life is not actually that easy, right? If you remember a few years ago, there was a DCOS and Kubernetes today and Service Fabric, normal Service Fabric today. This is like, I want to go through a simplified story of how you would normally deploy a container in a cloud, right? So first you write some code. This is the best part about deploying a container. Then you write a Docker file, which describes your code, how to build it, and how to package it in an image. Then you build the container, push it to a container registry, like usually Azure Container Registry or public registry, doesn't matter. Then you go and decide which cluster you want to create, which offering you choose. It is a Azure Container Instance, there is Azure Kubernetes Service, there is Service Fabric, and probably lots of others. Then you go and start configuring the cluster. So you configure a lot of things, and one of them is just routing, security, size, and auto-scaling of the cluster, auto-scaling of the applications, and all of that. And that's where most of the companies stop doing stuff, right? They never get further because there's so many things to enable and so many things to secure that developer find a new job, right? But let's say you got past that, which is not realistic. Then you start thinking, well, I've got a few microservices, so my life is really complicated. I need some sort of package manager, right? And in Kubernetes world, it's Helm. So I just put it as an example because it's probably one of the most well-known ones. Then you go and repackage your application with this Helm package manager because you don't want to use Docker file anymore because they're not cool. Then you push again, both your containers and your chart. Then you redeploy and go and fix the cluster because everything crashes on the first attempt. Then you go and babysit the cluster all the time because it keeps crashing because the operation team probably didn't configure routing properly or cluster storage or anything else. So that's basically rinse and repeat all the time. So, after this procedure, and then this is just a simplified workflow, it's actually thinking like, why do I need containers? It's actually not easier because I can just write a console application, and run it from my laptop and just tell everyone I've deployed it to Kubernetes. It works, pumps data, it's fine. So Microsoft probably, as other companies, have the same set of problems. So they thought, what if you could essentially develop your code locally and fast, right? So not run Docker all the time, not wait for the images to be rebuilt, and that's not a fast procedure. You could simulate a local cluster on your own machine without upgrading to some sort of Alienware latest model with 32 gigs of RAM, probably 64 because you need the first 32 to run Chrome, just basically use a laptop for development, And also, it would be nice not to learn all of these new frameworks which appear and disappear all the time, like even Helm or Captain. There are so many technologies you can glue your cluster together with. You could also skip conversations with your local DevOps team, right? Because essentially, every time I personally come over to them, I see a bunch of like crippled people which sort of like say no to everything, you know. So, you know, if I have a choice, I would rather trust Microsoft rather than my local DevOps team. And I'm not talking about all of the DevOps team, just mine, yeah. You know, well, I've been doing containers for the last 2 years, so I work in 20 places. I'm just kidding. Yeah, we can chat about that later. So what if you could just do it, you know? That would be cool, right? So this is what Service Fabric Mesh is about. So you could get a framework which would allow you to write code, and you could just run that code without talking to people, without setting up this infrastructure. Just push a button and run it. So Service Fabric Mesh, it's got a new logo. Instead of a rounded, it's now square and turned a little bit. It's not your Service Fabric. It's not the usual Service Fabric. It's built on top of Service Fabric. So essentially, Service Fabric Mesh is a thin layer on top of Service Fabric with more developer-friendly technologies, more like developer, easy-to-use interface, essentially. It doesn't really ask you to manage any infrastructure at all, right? But you could argue with that because essentially none of the other technologies ask you to manage the cluster unless you run on-premise. So whatever you used before, I don't want to offend anyone from other cluster technologies, but you know, even with normal Service Fabric, you have to manage infrastructure. Although it's virtual infrastructure, you still have to manage it. Same with Kubernetes, same story. You manage nodes, you babysit them. Yes, Azure creates it for you, but you still have to watch over them. So Service Fabric Mesh essentially says you don't have to manage virtual infrastructure as well now. So just forget about it. Just like with Azure Function, I push my function, it runs. Now I push my container, it runs. That's the idea. And it allows you to utilize your technical skills instead of conversational ones. It's another cool feature is integration with Visual Studio. A lot of people love Visual Studio because of its visual workflow and developer friendliness. You have a good set of tools which integrate with essentially anything you want. And it's just nice to have for technology, especially the technology you don't want to invest in and you want to just play with to see if you like it. Visual Studio is a great tool, and Mesh integrates with that. And I'll show you in a second how. So another cool thing about Service Fabric Mesh is that it compiles into ARM template. So there is no binary output, it's just ARM. And you can take that ARM and deploy it either from Terminal or from Visual Studio Code, or whichever tool you prefer. It's just a JSON file. You wonder how already, but I'll show you in a second. You can describe your application as a YAML or JSON file. It doesn't matter, you can choose the syntax. It's very similar to Kubernetes manifests as well. Very, very similar. You'll see it in a second. It allows you to age slower because you don't have to fight with people to sort of ask them for permissions and ask to approve, can I put that checkbox there in Azure, right? And because of that, you don't need to buy a Headspace subscription. The Headspace is a meditation app, which I use every time I talk to the DevOps team, right? It also simplifies all of the principles about application development. So it says that your application is a set of services. It starts with a very simple terms. So services are what you usually call microservices, but in reality, in reality, microservices rarely work by themselves individually, although they're supposed to. But imagine you have a company set of microservices, you try to deploy one without other microservices, it's actually pretty much useless. They rely on each other about functionality. So Service Fabric Mesh says, well, forget about these isolated microservices. You can have something called an application, which consists of microservices. And the application is an atomic piece of deployment. It either deploys with all microservices or it doesn't. But services are still independent of each other. They don't know about the existence of each other. They are containers. Yes, they are microservices, of course. They can only communicate with each other via the network. So same as any other container orchestrator. It's essentially a container. It has its own address, totally isolated entity. Again, you can use any OS language and platform with Service Fabric Mesh. It doesn't matter. You use Linux, Windows, C#, Java, whatever you choose. And the application is something called, if you think about Kubernetes community, they invented something called help package manager because of the containers actually don't live separate in reality. So you can think about a Service Fabric Mesh application as an analog to a Helm chart in Kubernetes. Of course, this is a simplified model, but in reality, Service Fabric Mesh application can look something like that. The application can have volumes, which at the moment only Azure File and Reliable Volumes are supported. Application can have its own networks, like VNets in Microsoft Azure. It can have gateways with routing rules, whether it's TCP or HTTP. So if you developed an API or website, you probably use something like URL rewriters, or if you used Kubernetes, you probably used traffic or, I don't know, I can't remember the other name of the tag. So you would usually have to install that on top of your cluster, but with Mesh, it's just all built in. Then every service can choose OS it runs on. So it actually gives you a hint that a single application can use a mixture of OSs. It doesn't have to be a single one, which none of the other orchestrators support. It's either one OS or another. It's obviously, service can reference the network it runs in. Service can define how many copies or replicas it can use. It can define auto-scaling policies. You can say, if my CPU jumps over 50%, add another node or something like that. Then it also has something called code packages, and code package is essentially a Docker container. And those code packages can have endpoints and configuration, resource limits. So again, the possibilities are endless with Mesh. Yes, please.
Quick question.
Yeah.
How about VPNs?
VPN, well, it's not part of Mesh. You can bundle it on separately.
But for example, if I hold my service and I have still a server on my data center, like SQL 2008, I rely on big data.
Yeah. Yes, potentially you can define a network under your application manifest, which references the network your VPN uses.
So I have to configure VPN separately,
Yes.
but just define to use that network,
Yeah.
which should be available.
Yeah. Yes, you can essentially reference it. Yeah. So instead of creating a new network, it can reuse your existing one. Yes.
Sorry, to follow up on that, then does a VNet constrain you to something like an app services plan, considering that it's serverless, and so it's kind of conflicting or not very clear on how you define a VPN, where you deploy your mesh?
So at the moment, because it's a preview tag, you can't, but you can. In a few months, you will be able to choose which network you want to put it in. You can combine multiple applications in a single network, and you can connect VPN to that network as well.
So is that going to be a different plan that they're going to offer as part of Service Fabric itself, or is it part of any other type of service plan as part of Azure?
You will be, I believe you will be using the same VPN technology used today, but instead of creating a new network, you can reference Service Fabric network, right? Cool. So let's move on. The code is coming, I promise. So this is the typical workflow if you develop containers locally. So no matter which container orchestrator you use, you first write code, then you build it inside a container, then you package it into a container, you push that container, run it, or if you're talking about a local workflow, you just run the container, right? Every time you change the code, you have to rebuild the container and repackage it. And sometimes it takes minutes and minutes and minutes. Sometimes it can take half an hour, depending on how many references your application takes. Of course, you can not use containers, but then you're risking into running a situation when your local environment is different from containerized environment. Service Fabric Mesh also solves this problem, and it allows you to do the following: just code and run it, and all happening in containerized environment. The way it does that is very interesting. So it packages every service you developed into a separate container, just like with other technologies. However, it doesn't package your application inside that container. It injects the SDK of your language you write in the container. It also installs remote debugging agent and just runs it all the time. Then it mounts your local disk subfolder to a container. And every time you make changes to your code, they are immediately available inside a container. So it seems like a very simple idea, but it allows you to change code it and run it immediately without constant recompilation of the container. So instead of half an hour, it takes probably a few seconds to run it again. Right? So this is all I had in terms of boring slides. And if you have any questions before I start showing you the code, please shoot. Yes?
You did mention about gateway, right? So does that mean gateway is not required, like application gateway in Azure is not required for Mesh? And does it have its own built-in gateway?
Yeah, so Mesh has its own built-in gateway. So it's essentially they use an open source gateway called Envoy proxy. The rules for the routing are very similar to Envoy. They are a superset of Envoy. Right? It's actually very interesting. I'll show you in a demo how to use those rules. You don't need to install anything. They are just available all the time.
And they don't charge you for it?
No. Yeah, you don't have anything like an Envoy node running in a cluster or even Envoy application, which you have to pay for. It's all free. So in Mesh, you are charged per second of your application running. So even if you destroy a container, you stop paying for it. That's how it works. Right. So I just wanted to quickly show you Visual Studio tools for Service Fabric Mesh. So all the technology is in preview, as I said before, and the tooling works only with Visual Studio 2017. If you use Visual Studio, or you can use just a terminal or notepad, then it works regardless. But I wanted to concentrate on the simplicity of the workflow in Visual Studio tools specifically. Yeah, this is Visual Studio 2017, and after I installed the extension of Service Fabric Mesh, I have a new item appearing in my IDE, Service Fabric Mesh application, right? Let's say I would like to create a console application and just run it, right? So, demo app. So now you have two options. By the way, you can only use .NET Core with Mesh. If you're using .NET, you can't use classic framework. I mean, theoretically you can if you create the project manually instead of Visual Studio. But because you also have a choice of containerised, it's either Windows or Windows. It will be Linux. Let's go with Windows. So Microsoft is going to support Linux. I mean, it's already supported, don't get me wrong. It's just not in the IDE selection box. You can just type it manually in a manifest, and it will run. Then, because it's just a preview plugin, it supports just ASP.NET Core and console application. And to be simplistic, I'll just say console demo, create a console application. I only want to show you a workflow, how easy things are. Right. Right. As you can see, just ignore this item for now. So I just wanted to have a look what actually is created as a Visual Studio template. Right? This is a simple console application. There is no magic in it. So this is a Service Fabric Mesh application. Can you see the difference between normal console application? Right? Because I can't really. The classic Service Fabric actually generates a lot of boilerplate code to run a simple line of code. In this case, it's just a console application. I'll just prove it to you by trying to edit CSproj file. As you can see, output type is exe. Right, wrong way. Ooh. Okay. Okay, got it. There is some helper text for Service Fabric, which you can delete. From my experience, it doesn't make a difference. And it includes a preview version of the Service Fabric SDK. Right? At the moment, there is a bug that it only supports 2.1, only from Visual Studio. Of course, you can use even .NET 3 Preview 6 if you want to. This is only a plugin bug. And that's it. There's nothing else. It also generates your Docker file, a stock standard Docker file which compiles your application using .NET SDK and runs it. So the only thing it adds as an extra is a YAML file which describes your application. Right? And as you can see, we have just a few simple things. So there's a service name. There is some human readable description, OS, Windows or Linux. I can just type Linux here and it will run Linux. But if I press F5, it's not going to run because you need to deploy it manually to Azure because Visual Studio doesn't understand Linux format yet. We created something called a code package called console demo. This is a reference to a Docker image. And we say we want to limit the resources of this microservice to 1 gig of RAM and this amount of CPU, which comes from parameters file. Which brings me back to another project created by Visual Studio, demo app. As you can see, the parameter value is half a CPU. This is, by the way, another thing about Mesh. It allows you to request a fraction of physical resources as well. So if I say I want 0.1 CPU, I will only pay for 0.1. If I stop running it, I'm not paying for anything. Right? So when I compile this project, the only thing which happens is obviously Visual Studio creates a console application, And another thing it does is compiles the Docker file. So as an output, you will get a local image in a Docker registry, right? So before we actually run something interesting, let's have a look at this demo app project, right? So this is a wrapper generated by Visual Studio, which describes the whole application in YAML files. That's actually brilliant. 1 second. So you remember my diagram, it has application on top. So application is described in the app.yaml file. In this case, it doesn't contain almost anything. So there is application name and human readable description. There is nothing else to describe. Then one of the resources Service Fabric Mesh supports is a network. So we have network.yaml file where you can describe how your network, which is surrounding your application, should look like. In this case, we are just saying, well, there is a network address prefix, so all of my containers will have the following IP mask. And we say this is the local network, which means private to your application. Yes?
So you mentioned that application acts as a helm name, so it should track versions. So where do you register your versions and you deploy like a few of them and you want a rollback and so on? Because what you show is just literally a description and nothing else.
Yeah, so it doesn't track versions of the actual services because it offloads this task to a Docker, right? So when you build a Docker image, you can tag it appropriately with a version number and push to the registry. And then you reference the Docker image from your service with an appropriate tag. So in this case, the version number is just dev, but you can put something like 0.1, 1.0, whatever. So you version images, Docker images, but not application manifests.
Is there a possibility of doing deployment with this kind of model?
Yes, but I don't know how.
Like for example, the earlier service fabric would say it would let you upgrade the application version, like so once you deploy. Whereas
Yeah, so in terms of deployment, because this runs on top of Service Fabric, you got rolling upgrades, which normal Service Fabric does anyway. So if you don't remember how it works, so you supply a new version of the application with new versions of services. They might be new, might be existing. Service Fabric looks at the difference if it needs to upgrade something. Then it tries to deploy a new version and run it for a little bit. If it's fine, it kills the previous version, and it keeps rolling and rolling all the time. And this is built into Service Fabric Mesh as well.
but side by side is not possible with this model. So like,
Why not?
Like let's say you have version 1 and a version 1.1. You can't do a side by side deployment like in the earlier where you could have application names for the version name and application types for the version types.
I see. You can do that by simply, where is it? Simply choosing a different name for your application. You could say demo app 1, demo app 2.
Right.
Yeah.
It's not that clean, is it?
You can introduce a parameter for it if you want to. Because parameter support is built in, like you can see, Service YAML references a parameter called CPU. You could potentially use this parameter in a name and just call it whatever you want. If you fancy the old style application types in Service Fabric, just do that. What do you think of my idea? Huh. Well, containers, they rarely get to production, right? But yes, you can do that. It's part of the it's part of the this YAML specification that you can use parameters. Just like in Helm charts, you can use parameters, but you have to use Go crippled template language. This one actually allows you to have nice expressions in a readable way. Right. So let's try to run this. I am having errors. I have probably changed something in my service definition, which I shouldn't have. Okay. Okay. So what's happening here is I pressed F5, and now Visual Studio tries to build a Docker image for this service. Let me just catch the output window. Okay.
Using Windows Docker?
Yeah. So I have a Docker running here in Windows mode. So it says switch to Linux container, so I'm in Windows mode. I could switch it. I could actually run it, but then I wouldn't be able to use Visual Studio plugin. Right. So this has already happened. The application just exited because just printed hello world. Oh, you can actually see it here. There we go. Can you see the output, hello world? This is what our program.cs contained. So
it's actually not the whole Windows operating system, just to print.
yeah, it's Windows, and it's running a container, and I can prove it to you. So let me just try. I should be able to find my Docker image here. I think it's console 1, I believe. No, that's 5 hours ago. Oh, I think this is the one. Yeah, I just got lucky. This is the one. Oh no, 7 hours ago. Right. You just have to trust me on this. It's here. Console demo. This is it. Well, let's just say this is not right 7 hours ago because it's called console demo and it's running. So what else? I can show you the Service Fabric cluster view. So for those who used Service Fabric before, you remember this wonderful application, Service Fabric Explorer. And just to prove it runs on top of Service Fabric, you can see that this is essentially a normal Service Fabric app. No magic here. There is one service running console demo, which we just deployed, right? But you can't see anything in the replicas because it offloads the actual execution to Docker daemon, right? So that was just a simple example. Let me just show you what you can actually build. So I think a few months ago I had this problem with application insights. If I go back to my slides, I'll try to show you. So that was my problem. Application Insights. It's a wonderful platform, but it stores logs only for 30 days, right? What we wanted to do is to have the ability to archive those logs and to hand it over in future, in a few years, to data scientists to analyze behavior of our applications. We don't know the problems yet, but we want to have that data, right? So Application Insights has this wonderful feature called Continuous Export. So if you don't know what it is, it's essentially you can say, Application Insights, please offload all of the logs to blob storage. And instead of 30 days, now you can have infinite storage as long as you want, right? So I wanted to try the Service Fabric Mesh and see how useful it is. And I decided to do the following. I decided to write a service, and I called it Scanner, which would scan the blob storage and detect new log entries. Then it would just pick them up, put a task to storage queue that there is a new file available. That would be the first service. And the reason I can have it as a service is because I thought, well, this is actually good, but the console service is not actually a perfect solution to this problem. You could use Event Grid or Azure Functions because at the moment I'm scanning the whole blob storage, trying to find new files. So this is not effective, so probably I can just use something more cloud native later, right? Therefore, I could replace that component in future. So I wrote a second service, called it Importer, which subscribes to that queue and downloads the files and moves them to storage tables. So essentially, I can free up continuous export blob storage by deleting the files there, right? So I would know they are safe there. The third service I wrote, which is called Condenser, I don't know why I call it like that, is to pick up files from storage table, compress them during period of time, let's say 1 day, convert to another format, Apache Parquet, if you heard about it. It's a native format for Apache Spark, really good for data processing in big data scenarios, and write it back to blob storage. So the data science team can actually utilize that later, right? This is what I had in mind, and I can show you the final application, how it works in Service Fabric Mesh, and we can go through details in a bit. Right. Sorry, technical problems. Right. And here's the application. So I called it AI Exporter, right? It consists of 3 services I just described, Scanner, Importer, and Condenser. So they're all console applications. As you can see, it's program.cs. I used just open source libraries, and one of them is storage.net, really cool one, which abstracts the underlying storage technologies. So because I could switch to AWS tomorrow, maybe, so I could just use abstraction instead of hard coding Azure storage blobs. Or maybe I want data lake storage, so maybe Microsoft convinces me not to go to AWS, but use something else. Then I will, of course. So essentially this service, as you can see, creates 3 endpoints, one for exported blobs, one for message queue, and another one, I don't even know what this is, sorry. Probably to save state of the application, right? Then I invoke my class file scanner and just really run it every 10 minutes or 5 minutes. I think 10 was too much, so I changed it to 5. So it essentially rescans the blob storage, really, really simple, and pushes files to the queue, right? So if I would look at it in Storage Explorer, this is my blob container where I configure application size to offload all the data. You can see it looks like this. Right, there's tons of date time folders with hour and small JSON files which have blob suffix. So that service would just pick them up and put in a queue. The queue is already cleared because I've deployed this application, so I apologize you can't see it here, but actually you might be able to see the logs. Essentially this is what the service does, right? This service, the second service importer, and before I forget, let me just come back to the scanner, right? Let me show you the service manifest. So as you can see, it's very simple. While you can see these keys, please write them down because these are production keys to the Azure storage. As you can see, I just define a service name, like in a simple application. I use something called environment variable to store secrets in my code. And so I can pass them to the application. I use something called Service Fabric Volume to store the state of my application. I didn't talk about this, but Service Fabric supports different volume formats, just like Docker does. The first one is Azure Files, and the second one is Service Fabric Reliable Storage, which maps directly to Service Fabric Classic collections. It allows you to have a local high-speed disk as well. So you can essentially utilize it from your application as file storage. Then I limit the application to half a CPU and half a gig of RAM. Just want to have one instance and reference the network I created, right? So no magic here. Normally in production, I wouldn't use that, of course, but I like it because it's quick. Again, the importer service does a similar thing. So it creates endpoint for message receiver, for blob storage and table storage, and essentially will move the files. Let me just show you. It will move the files from this queue into a table storage AI events. So I left one record for you so you can see that's the format of this record. This is the original body of application inside. Probably hard to see. It's just a JSON document. Right? Sorry. And the third service takes all of the records and compresses it into Parquet files. Right. So also very similar code, 2 endpoints, source key value storage, which is Azure tables, target storage for writing Parquet files. Then I will use this amazing open source library, Parquet.net, which supports Parquet on .NET platform natively to create Parquet files. And that will write back to blob storage. Sorry, let me just go to the root folder. It will write the Parquet files to the blob storage. As you can see, like the sizes of these Parquet files are actually quite small. So 4 kilobytes, 2 kilobytes, and this is the event data for the whole day, essentially. Well, normally it's a few megabytes per day in JSON. So we achieved what we wanted in terms of compressing data logically. So any questions about this app? Yeah?
Can you show the networking between the services? How it's defined?
Oh, okay. So this application is actually not using any networking between the services because it's using third-party components like blob storage and queues to communicate between each other. However, if I would want to use networking, I would show you another app. Sorry, this is not the one. There's another sample app I wanted to show you, which consists of API and a website. So both are ASP.NET Core applications. The API essentially has one controller, which returns a random live fact or something like that. The website essentially just calls this controller over the network, right? And I'll show you how this is constructed. So first of all, I would create a network, internal network for my application. But by default, this is not accessible from the internet. It's only internal network, so all my services will have these addresses, right? Another thing is, let me just show you. So if I go to manifest on my website, which calls web API, I am calling the web API using the following address, like facts API.2APIs port 80. And this is because of the automatic DNS resolution in Service Fabric. So the first part, facts API, whoops, sorry, my mouse is gone. So facts API is the name of the service. The second part is the name of the application, and then port. So I hosted on port 80 because every container has its own IP address, so ports can clash. It doesn't matter. This is like a simplistic explanation, right? So essentially, it's not actually the service name, the first part. It's the name of the service endpoint. So the service can expose multiple endpoints on different ports, different protocols, but I named this endpoint the same as a service. So just to show you in code what I actually mean, if I go to API service definition, if you can see here, in a service manifest, I would describe an endpoint. Right? I'm exposing it on a port 80 and call it the following way.
So the listener is extra name. So the actual name of the endpoint is facts API.
Yes. There is a strange, well, let me just show you 1 second. Yes, so facts API, it should have a reference here. Okay, I think I might have screwed it up a bit. So the thing is, I could use either that or that, but because I have a single endpoint, by default, it will just understand both formats.
But you're pointing to the image name, not actual name.
Image naming as in here.
It says image, so that's a container name.
Sorry, not
So
sure.
when you say you can point to one or another, you mean I have an endpoint which is being exposed for actual service name, but not container name.
Yeah, but the service name is the same, so it probably figures it out, isn't it? If you look higher up.
Yeah, so when the service starts, as you say, there will be a few DNS entries. One DNS will be for the actual service name, and another one for the endpoint name. And if you have more endpoints, there'll be more DNS records. So you can address the service by either.
So you have DNS auto-discovery.
Yes. And so DNS does load balancing by default as well in a round robin, I believe. You will be able to choose more policies, more mechanism for load balancing once it goes past preview, but this is the default behavior, right? One of the other, so the last thing I wanted to show you is gateway support. So in this particular application, I defined a new resource, gateway.yaml. This is because I'm hosting 2 HTTP endpoints, but I have obviously one single public IP address. So what I want to do here is when user hits the primary IP address, I want to open a website. If they have it with /API/, I'd like to forward them to the API service, right? So Mesh allows me to define these gateway rules natively, right? So I can either do this, which I commented. So I can say, I want to define TCP gateway policy, which based on the port number will choose one or another address. And that was the issue with normal Service Fabric, that you didn't have a built-in gateway. You had to use some third-party solution like a traffic. But Mesh supports HTTP level routing as well. So you can say that I want, based on a URL shape or query strings or something else, you can have rules based on HTTP headers. There's quite a long list of what it supports. You can redirect traffic to particular service and load balance it between each other, right? Just to show this in action, I've deployed it to Azure already. Let me just open the portal. By the way, in Azure, you can't see clusters, Mesh clusters anywhere. They don't exist. So when you deploy the application, you have applications as resources in Microsoft Azure. When you delete the application, everything's gone. You have no traces left. So just like Azure Functions, they are totally serverless. They don't have underlying cluster, or at least you don't know about it. While this internet loads, let me just show you the output of the build, right? Let's come back, let's say, to our demo app. And look at the output of Visual Studio, or you would achieve the same with MS Build. Resources. Okay, let me open something more interesting. So look at this. This is essentially a build output of the whole application. There is no binaries. These files are just temporary output, which you can just delete and ignore. That's the parameters, and that's the actual build output. I'll open it with VS Code, because it has ARM viewer, a good one. And the output of Mesh application build is just an ARM template. So we've got a couple of resources. There is a Mesh application, which is a native ARM resource. There is a network, which is also a native ARM resource, very small definition. And there is a gateway, which is also ARM resource. And you can even see that the routing rules are declared in line in the ARM template. So this is how cool it is. So you don't need to come back to your application to customize it. You essentially open this ARM template. You can even add it to Git to version control it, because once you've prototyped your application and you think, well, this is fine, you don't need to regenerate this. You can put this ARM template in your CI/CD process and deploy the microservices using the tools you're already using. 205. I can make it one line if I put everything in one line. Or split it in files, different files. I don't know. There are ways to do that. Okay, all right, let's go back to Portal. So here we go. So there is a resource group and AI exporter application and 2 APIs application. Right? There's no cluster, nothing. This is the resource group view. Right? I go to AI exporter. And what you should see is the list of microservices inside this application. We got scanner, importer, condenser, You can see number of instances created, 111. I don't want to pay for more for now. Service count, you can drill down into services, see what's happening. Like we've got one replica, can click into the instance 0. So in instance 0, we have code package, which is a Docker container. Oh, by the way, I'll just go back quickly. Thank you. Sorry, we've got to click in again. Scanner. The first replica. You can see that the container image is here, and it's referenced from private Docker registry, right? This is ACR instance. And also Visual Studio automatically tags them with current date and time, but you can customize this as well. So if Microsoft is saying they're using Docker technologies, they're not lying actually. You can see the event log, high-level events, more details about the service. You can see all my passwords here because they are in application configuration. That's very convenient, so you don't need to ask admins for access. You can even see the application logs. This is a raw Docker logs coming out from console output of the application. Right? It's found some files, and none of them are new, and it's been scheduling for processing, just normal developer logs. What else? If I want to delete the application, I just sort of tick it and just press delete, and it's all gone. I'm not charged. There is no background clusters running, nothing. Yes, that's it. It's gone. Yeah.
So let's try to sell this as a serverless, isn't it?
Yeah.
Does it scale down automatically? Because, for example, on GCP Cloud Run that we are promoting, we have this automagic. And now if you don't use it, it scales down after some time, and when you hit the endpoint, it spins up. Is it happening over here as well, or you have to
You have to have at least one instance running, right?
for a service or for application?
For this service. So application, I'm not sure if it can have 0 services, probably not. It will just fail. This service needs to have at least a single instance.
All right, so it's still burning money if you don't use your services.
No, you don't. No, of course, you need to run at least one instance,
Right.
yes.
So it burns money.
Yes. Yeah. Yes, but we're helping Microsoft to earn money. So.
How about security, let's say, because you expose your credentials as environment variables. Does it support like secrets?
Yes, it supports native integration with Azure Key Vault, and it supports secret encryption as well.
So by
yeah.
Key Vault, you mean you can reference a record in a Key Vault?
Yeah.
Or KMS encryption, which you have to encrypt your data and then it decrypts because you have to provide stuff in that host?
No, you can. So you can reference Key Vault secret from the ARM template. So the secret is another native resource of Service Fabric Mesh. You can essentially in ARM template describe that this is my this is my Key Vault instance, and this is the secret name and the version, right?
So during the startup, it's going to fall.
Yeah, exactly.
Plus your
Oh, sorry, thanks. So it also supports, not in the current preview, but next preview is coming with managed service identities for service instances. So you can have managed service identities per application, per service. Unfortunately, not to replica level, but you probably don't want to. Right? So in terms of security, there is a strong story Microsoft is promoting. So the reason it's a bit slow is because there are probably some changes, more or less major or minor, coming to Service Fabric Mesh, which might make it much better. There are changes coming to the YAML files, as Jack Daniel said on YouTube, who is the Service Fabric PM, which will probably make these YAML files very similar to Kubernetes resources. Yes. Yes.
How about SSL certificates? For example, if I expose my endpoint, where
Yeah.
I should upload it, or if it's actually supported?
That's not supported in the preview, but this is also coming. I don't have any timelines, but I understand none of the production applications can go without SSL. So, you know, it's probably not going to go to production without SSL support.
So it's just early days for this service.
Yeah, I don't have details how it's going to be implemented, but you know, I trust Service Fabric team.
Any rough idea when it's going to be
Sorry.
generally available?
Oh, sorry.
No, I mean, do you have a rough estimate of when it's going to be generally available?
Sorry, could you say it again?
A rough estimate of the timeline when it's going to be generally available in terms of the mesh?
So from what I've heard, it's going to take a couple of months to hit the production, but more details are coming. Yeah. I mean, I would recommend playing with it now. The way you can do that is obviously Microsoft Docs website. Although it's previewed, there is actually a very good section. Right. There's a very good section on Service Fabric Mesh. They are pretty much up to speed with preview features, right? You can just Google Service Fabric Mesh, it's going to pop out the first thing, right? Then there's lots of code samples, again, on GitHub from Microsoft, which show you how to use secrets, how to use volumes, networks, other interesting stuff, basically everything they support. But of course, the best way to do it is watch my Pluralsight course, understanding the programming models of Azure Service Fabric. You know, that way I get some money and I can continue working on amazing content for Service Fabric Mesh. You know, and there is another course, build an application with Azure Service Fabric Mesh. Oh, sorry, that was for classic Service Fabric. That's for Service Fabric Mesh. Course for each. So the first one was just recently updated for Docker support on classic Service Fabric. So it's quite interesting. Yeah. Sorry, you had a question?
So is this completely immutable infrastructure?
Yes. Yeah, you can't change it. It's only so the only way you can change it is with ARM template. No other clouds are supported, but you know, the idea is that once you have a Docker image, you should be able to run it anywhere. And the quickest way to run it, if you go with Azure, is Mesh.
Yeah, no, because I'm asking because one of the nice things about Kubernetes is, you know, somebody else can develop something and it modifies your cluster as it runs, which can be good for, like, you know, cost optimization, a bunch of things. So that would be impossible, right?
No, but the thing is, when you destroy your app, it doesn't bill you for anything. So you don't actually have a cluster. You develop your app, you deploy it, and it creates the app in Azure. But you don't see anything behind it. You don't have any infrastructure. So it's like Azure Function. If it's deployed and it's running, you get in charge. If not, then there's nothing. So behind the scenes, yeah, Microsoft runs like an army of Service Fabric clusters with Mesh installed in them. It's a massive infrastructure from what I heard. But you don't have to pay for them, obviously. No. Yeah. Sorry. Any more questions, guys? Yeah.
Sorry, I did not see the service YAML definition where you would, or in the code itself. You didn't seem to, I didn't pick at least where you would define whether it's a stateless or stateful and that kind of thing.
Oh, I see. So you don't have a distinction in Mesh, stateful or stateless. They are all, well, you could say they're all by default stateful, because partially it's offloaded to Docker Engine, and it takes care of scalability. The stateless part, to be honest, I either don't have much details on it or I can't disclose it, but it's, you have, so no matter which service you write, you can always mount a volume to it, and that's the only way to actually store state today, because Docker doesn't have a concept of stateful service. So you know, it's like it's an interesting question, because if you would have stateful services, you wouldn't be able to migrate to another container orchestrator, because it will be Service Fabric Mesh specific. Right? The idea is to have portable workloads. Yeah, sorry.
I've seen that in the code sample you were referencing package, you get a package like Service Fabric Preview,
Yeah.
whatever. What's that used for?
So this is a MS build task. You
It's
don't.
just a MSP task.
Yeah, so you don't need to reference it at all. You can delete it. So the only thing it does is it transforms the YAML file into ARM template, right? So if you already transformed it once, then you don't have to do it. This is just for convenience. So yeah, you change YAML, and you don't need to go and run some console utility. You press F5, and it regenerates it for you. So that's it.
So for example, if you were to run, I don't know, I've seen that it wasn't compatible with .NET Core 2.2.
Yeah, that's right.
Yeah. But I mean, if you can do without that part of the automation, you could potentially do it or run any other technology.
Yeah, exactly. I mean, the thing is, the .NET Core is not really a point anymore. So
Yeah, exactly.
no, it's a Docker image, and it can be anything. You know, any language really. Yeah.
In the example with website and web APIs, what kind of potential are you seeing in the communication between those two layers?
That was plain HTTP. So if you're asking about remoting, it's just plain HTTP calls using HTTP client. You know, there is no magic, nothing specific. Again, because there is no native stack for communication. There might be, but again, it's going to be specific to Service Fabric. And if you go with containers, you probably don't want to use anything Service Fabric specific, because you want to port them. There is nothing built in.
And then internally it will run the private network.
Yes, yeah, exactly. Yes, so all the comms go inside the private VNet. They are physically close to each other. So that's why there is almost no overhead. So there will be, from what I've seen on YouTube, there will be a what is it called, a specific Service Fabric specific API, which you can call, just like with Kubernetes, you can call specific API to do like network discovery and load balancing, but then you stop being portable.
So if you have two applications with 3 services each, and one service from one application wants to talk to another service of application,
Yeah.
it goes how? Through application?
Yeah. Yeah, so there are 2 ways. So the first one is you treat the other application as totally external application, right? And they have absolutely no relation with each other, which will be the case if they're in different languages, platforms, and stuff like that. Or you can configure network bridging, but then you become dependent on the locality of those 2 applications. So which one's better? I don't know. It depends on use case. So the network bridging is not available in preview, but it will be later.
So safe side would be to use service bus for messaging and communicate through that way. It would be more reliable.
Well, not specifically. So service bus, you mean communicate between applications, right? Between different networks. Between services, it's only reliable if your services are unreliable, right? Because the message can just get stuck in a service bus and then come back later.
But they don't have naming service as a dependency
Naming service.
Like service fabric naming service, right? So they don't have that as a dependency in the Docker container.
No, they don't. No, so the Docker image is just clean. There is no service fabric packages anywhere lying around.
So you can't use naming service in it, right? I mean, there is no notion of naming service in mesh.
Yes, you can't. Well, you can potentially if you know that you're running in Service Fabric cluster, but it's not supported now. So you could, but you're probably going to be blocked because you're running in your own network and Service Fabric runs in another network.
Last question.
Yeah.
How about tracing?
Tracing.
Yeah, tracing.
So.
Do they have any like app insights that supports or like?
Yeah. So the support for Azure Monitor is coming for container monitoring. You can use App Insights as always, either from SDK if you use it from your app, or redirect the logs from Docker logs to App Insights. It's your choice.
Does it support just .NET or other languages as well?
No, any language. Yeah. So if you use SDK, the SDK is available for any language because it's just a REST API. Plus you have like in .NET you have NuGet package, right? In Python you have Python packages, and there are variants for other languages. So it's good stuff. You should use it.
But it's expensive, isn't it?
No, that's the thing. So you only charge per second of execution. So if you start using it now, you might get it for free for some time, I believe. You have some limitations. I think 5 cores in preview. I'm not sure if it's still free. I haven't seen it on my bill yet. But I believe you're not going to be paying more than for just Azure container instances or a container running anywhere else. Yeah, you charge per second of execution. So the price, I believe, is going to be the same as per second of execution on a VM with the equivalent resource requests.
What do you think are the advantages over, obviously in perspective, over AKS and Virgin Node, for example?
So the advantages I can see is just as a developer, I open Visual Studio or Visual Studio Code or IntelliJ, whatever. So I write my code and then I say, well, I want to run an application, and it just runs, right? If I go with AKS in a big company, I write my application and then raise 100 support requests, and then 2 years later, I try to run my application and AKS doesn't exist. Some new tag has appeared, right? So essentially, it's time to market. It's convenience and speed. So as a developer, I want to solve a problem and run on my application. I'm really not interested in infrastructure. That's the only bit. Yeah, and to be honest, I haven't seen any cloud portable workloads yet running on Kubernetes. It's not Kubernetes' fault, it's how the applications are architectured. So if we say a company is developing a set of microservices, they need to store storage somewhere, storage somewhere, they would use external storage for that, right? Because no one wants to host something like SQL Server or MySQL, whatever you want, inside Kubernetes, because then you have to make it really reliable. So you would go somewhere else, right? Cosmos DB, let's say, MySQL, SQL Server, to store the state of your Kubernetes application. But what you don't realize is that Cosmos DB runs on top of Service Fabric. So if you migrate, first of all, why don't you just run on Service Fabric in the first place? And the second one, if you migrate to another cloud, the Cosmos DB is not going to be there. So it's not really portable.
Is there something like Helm for Service Fabric?
Yeah, so the application model, where the YAML files, is essentially a built-in Helm. It allows you to do everything Helm does.
But you bound to Visual Studio?
No. No. No, YAML files, you can run them anywhere. Notepad, Visual Studio Code, Visual Studio. Probably VS Code is better because it supports better syntax highlighting for YAML. The standard is open. It's all documented. YAML is a superset of JSON, right? So you can use either. So Visual Studio generates the first JSON if you want to. Sorry, the first YAML Go if you want to, but then you're free to modify it anywhere. The CLI tools included in Mesh SDK, they have the ability to convert from YAML to ARM. This is how Visual Studio deploys it by itself. It essentially pushes the ARM template. Yeah.
Have you done any initial benchmarking in terms of performance of the traditional service fabric with, let's say, 5-node cluster or 10-node cluster versus the mesh in terms of performance?
No, well, to be honest, no. So the first thing is it's in preview, so you get a low priority CPU everywhere you run for now. And the second one, it's very hard to benchmark on different capabilities. So in terms of CPU speed, it's just a VM, so they're probably going to be equal. In terms of storage, because Mesh doesn't have storage as Docker doesn't, so there is nothing to compare against. Speed of scalability, we can't make judgments because it's preview again. It's too early to benchmark it, really. All right, guys.
Good stuff. Well, Ivan, thank you very much.
Thank you. Thanks, guys.
Some people don't like to ask questions from the audience, not a few of you over here, by the way. But I'm going to be around for a while. I imagine if you want to just come up and chat to him afterwards, a bit more one-on-one time with the fantastic international rock star, Pluralsight author that is Ivan. Feel free afterwards. But I just wanted to take the opportunity to reiterate, I think something that you said at the start, Richard at the start as well. The UK is your fund. This is the UK is your user group. We've been going for 8 years, and it's been funded in a very typical way. Last has put the money in, Hack the Boss put some money in, and that's been the way it's run for quite some time. But we're quite fortunate here, and none of those people want to put money in, and we get things like this for free, and we get some beers put at the back of Microsoft, usually 2. So I think we're a bit better today. We had at least 3 beers. I saw all scattered around the place. They must have had a management meeting earlier on today, so I think. But every other group around the UK finds it actually proportionally harder the further away they are from the big centres of commerce. And I think that the important thing for the UK as a whole is to have user groups of people, no matter where they are around the country, able to have sustainable funding. So one thing we're doing is we're helping put people who run groups in touch with people who have sources of funding, whether it's from the businesses that they run or whether it's some of the source of funding, that allows us to say, we'll do things like put a standard band thing up, or we'll do a video at the start of a talk, something like that. And that'll be 25, 50, £100 towards the operation of that group somewhere else around the UK. It's going to help make the UK a better place all around for Azure, and it gives exposure for people maybe like yourselves who may be doing like a software as a service app that uses Azure or something like that. You want to find more audience members, you want to find more customers. This is a great way for small, medium, and large companies to reach a whole different type of audience. It's very, very early days. It could go in lots of different ways, one of which is the bid. But what we're hoping is that this becomes something which is very positive for the UK. One of the things that we need is a set of funds, so a set of people who want to put money into this to keep it going. So if you think there might be something that you can get off the back of this, or influence around the UK, come and talk to me. But also, people, if you guys run, and there's a couple of you in the room who actually run groups in your your own right anyway. If you're interested in taking that to the next level, come and talk to me about that as well, and I'll give you more information about that. Hello.
Can you make integration with Monzo or Revolut cards? It would make things much simpler.
Possibly. Keeping up the asking questions all the time.
Yeah.
I like it, that's good.
There's just one click and you can donate and forget about it, you know?
Sure,
And
sure. I
especially
think
in the pub.
I don't think we're targeting individual donators so much, but maybe like businesses. But it's a good idea. And I was thinking, back in my mind has been this idea of should we do like a GoFundMe kind of crowdfunding kind of
Yeah, because
idea.
businesses, you know, it's just like if it's sluggish, if people, it's much easier. You can donate small fee and you get more out of it.
We've run the UK Azure User Group for 8 years. No one's offered to buy a beer.
Really?
Yeah. Just observing. Just observing. But anyway, if you do want to chat, I'll be here for a while. Thank you very much to Ivan. One more round of applause, I think.
Thanks, guys. Thank you very much. It's been a pleasure. And yeah, thanks, Richard and Andy, for the opportunity. It's great.